Okay, so now we're going to look at some different measures of spread and also another way of graphing some data, which is to make box and whisker plots. So to make box and whisker plots, we need a different measure of spread, which is called the interquartile range, or the IQR is what it's commonly abbreviated to. And to do that, we need to find some new values. So to start, we need to sort our data into ascending order. And this says if there's an odd number of values, remove the middle one, but I don't want to do that, and I'll show you what we'll do instead. But we do need to split the data into two equal size groups. The data that's in the lower half of the data, or the lower group, is called the lower, or what we want to find is called the lower quartile, and that's the middle of that group, the median. And the next one we want is called the upper quartile, or Q1 and Q3 is also what they're commonly called, because the median can also be considered Q2. And what the Q means, the quartiles, just means the quarter of the data. Okay, so IQR is commonly talked about as Q3 minus Q1, as well as upper quartile minus lower quartile, and that just means the same thing. Of course, we've got the range as well, which is a measure of spread, and together we're going to use the range, the interquartile range, and the median to make box plots. And remember that outliers affect our range, but the value of the interquartile range, which is our middle 50% of the data, is it's not affected by any outliers. So it can be a useful way of plotting it and looking at the data. So it's found in two different ways. It's different if we've got an odd number of values, for example, 15 data values compared to an even number of values. So I'm going to do an example of both now because it's found separately, differently. So first one says finding the interquartile range from an odd number of values. So we've got some data values, which are the results of a school maths test there. So the very first thing we have to do here is, again, is put in ascending order. So ascending order is the way to go here. So also when you've done that, make sure you've got the correct number at the end. So I'm just going to do that. I know you guys can manage that. So ascending order, 76, 79. Okay, so I've got 13 data values, which is what we started with up there. Make sure that you have that. That's really important. Now, so the middle value here is going to be 73. So in this case, our middle number, which is what is going to split our data this time, this is still our median. Remember, we found that before. And in this case, the median is 73. So that's our middle of our data, which means the rest of it is now split into two groups. So we've got a lower group and we've got an upper group. And the lower quartile, or Q1, is what we're going to call it, is the middle of that lower half of the data. The middle of the lower half. Now let's have a quick look at how many values we've got in that middle half, that lower half. So we've got 1, 2, 3, 4, 5, 6. 6 values. Now we know that the middle of 6 values is actually going to be the average of the two in the middle. Because it's not an odd number and we can't have an even amount on both sides, we need to find the average of those two middle numbers. So to do that, we're going to add them up and divide them by 2, just exactly like we did before when we were finding the mean from an even number of values. So 56 plus 62 divided by 2 is going to give us 59. So our first quartile is Q1 is 59. Q3 is found in exactly the same way, except this time we're looking at the middle of the upper half. So the next section of values, the values above 73, above our median, and our 2 in the center here are going to be 81 and 85. So again, we do the same thing, but we do it with the upper half, which means we're going to get up with 83. Now, interquartile range is found using those two values. So now we can find that. The interquartile range, which is found by taking Q3 minus Q1, is 83 minus 59. and it's 24. And what that means is there's 24 values in the middle section, the middle 50% of our data. And that will become a bit more clear when we look at a box plot, when you can see that visually. But that's what that means. All right, let's have a look at an example of doing the same thing, but this time we've got an even number of values. So exactly the same way, we need to put in ascending order again. So same situation, and again, let's just quickly do that. 8.2. 9.2. Okay, now because we've got an even number of values, we can actually just divide it straight down the middle, and that is going to be with we've got 10 values, it says that here, 5 in the lower half and 5 in the upper half. So in this case, like we found before, the median is going to be the average of those middle two. So you can see it's going to be the opposite this time as we found just above there. So it's going to be the average of the middle two values, which is 8.2 plus 8.3 over 2, or in other words, 8.25 is our median. Q1 though, in this case, because we've got 5 values in each half of the lower half, it's going to be a single value on its own. The middle of each of our sections of data is going to be a value on its own. So Q1 is still the middle of the lower half. That's not changed. However, the middle of the lower half can be found just by looking at it. It's just one value, 7.1. Similarly, Q3 is just one value, 8.8. So our interquartile range is going to be 8.8 minus 7.1, or 1.7 for our middle 50% of the data. A good way to look at this visually is to look at a box plot, and or sometimes it's also called a box and whisker plot, and it's called that because it's got a box in the center and 2 whiskers on either end. So what makes up this type of graph are our maximum and minimum values, our median, and our quartiles that we found just a second ago. So if you have a look at this graph, what it does is it splits our data into 4 quarters, hence the name quartiles. Quarter of the data is spread in each section. So the bottom and the top whiskers contain the lower 25% and the higher 25%, and the middle section, the box, includes the middle 50% of the data, and the line that goes down the center is the median, which is how that is split. So once you've got those values, which we have before, we can easily plot our box and whisker plots, and it's a good way of visually showing where most of our data, what range it's falling between. So I'm going to plot those values we just found before. So for our odd values, let's draw a box plot for that. So the first thing we need is a scale along the bottom, so to some type of straight scale, and usually you have arrows on either end showing it is still going. So the values we were working with here, the minimum was 19 and the upper was 96. So we need quite a long range of data here. So I might go as high as 10 and up to 100 here. So 10, 20, 50, 60, 70, 80, 90, 100, or just whatever fits. So we've got 1, 2, 3 extra. So we could start at 0 and go a bit higher than that even. 40, 50, 60, 70, 80, 90, 100. And it really wouldn't make sense to have more than 100 actually here, because we're talking about marks in a test. So I am going to finish that one there, although it's made my line a bit crooked now. Please have a straight line. Please use a ruler. So the easiest way to plot this is to just plot those values that we had before. So our lowest value, put dots where they are, is 19. So that's approximately there. Our Q1 value was 59. So that is going to be here. And if you do them all in a line with a ruler, that is going to make it very easy doing the box and the whiskers. Our median, our Q3 was 73. So somewhere around there. Our Q3 is 83, so again somewhere around there, and our highest value was 96. So let's say approximately there. So there are 5 dots. They're also called the 5-number summary. If you ever see that written, what it asks, what it's wanting you to do is plot these 5 values. So draw the box first. Use a beautiful ruler. Draw the box around, and you draw a line through the median as well, and then you can join up the whiskers. And if you use a ruler, it'll be nice and straight. But what it's showing is 50% of our students in this class got values between 59 and 83, and there's some outliers that go up as high as 96 and also down as low as 19. But most of our students achieved in that middle range. If we want to quickly plot the next one too, that works in exactly the same way. So again, the scale, the scale is dependent on what data you're working with here. So, and the line depends on what you want to make it. So our lowest value is 5.1 and our highest is 9.2. So I might go 4, 5, 6, 7, 8, 9, and it can go a bit higher than that. So 4, 5, 6, 7, 8, 9. So 5.1 is our lowest. So again, 5.1. Our Q1 is 7.1, so around there. Median is 8.25. Q3 is 8.8. And our highest value is 9.2. So you can see that it's not in the center of what I've drawn. Of course, you could have chosen values in different values for your scale, and it doesn't have to be in the center, but it probably is good practice for that. And of course, we should have titles here. So if you know what the data is about, put titles on your graphs as well. Okay, thank you.